How many types of LSAs do we have? 11 types of LSAs, but out of this, we will not be discussing all of them. These are all the LSAs that we have in our OSPF. Router LSA type 1, network LSA type 2, type 3, network summary LSA, type 4, ASBR summary LSA, type 5, external LSA, AS external LSA, type 6, group member LSA, type 7, NSSA external, type 8, external attributes LSAs, and type 9 to 11, they are not nothing, they are opaque LSAs. This is just to have an idea what are the LSAs we are having. And that we will discuss about. We will discuss means briefly we'll be discussing about these three, okay, and we will be having just an idea of all these three. Type 4, what is type 4, type 8, and type 7. Type 1 generated by every router in an area. Type 2 is generated by only DR. Type 3 only by ABR routers. Type 4 even by only ABRs. Type 5 by ASBRs. Even the type 7 is also by the ASBRs. Clear? As we have discussed already, this red one is, sorry, this green one is area 1. Red one is, sorry, area 0. This red one is area 1. Blue is area 2. Brown is area 3. And green, this light green is again the parrot green is again the, whether it can be AJRP or RIP, whatever it can be, another routing protocol. R1, R2, R3, R4, 5, 6, 7, 8. R2 is a backbone router. R1, R3, ABR routers. area border routers. R4 and R5 internal routers. Even R6 is also internal router. R7 is ASBR, autonomous system border router. Clear? These are the major roles of routers in OSPF. Okay. Backbone router, a router which is having all of its interfaces in backbone area, that is area 0, is called backbone router, R2. Now R1 and R3 are ABR routers, which are having interfaces in multiple areas and at least one interface in area 0. And here R1 and R3 are the ABRs. R4, R5 and R6 internal routers which are having all interfaces in a single area but not area 0. If you area 1, R4 and R5,
R1, R3,
ABR, area border routers. R4, R5, R6, these routers all are having interfaces in a single area but not the area 0. If it is area 0, it will become backbone area. Other than backbone area, those routers will become internal routers. And router which is having interfaces in multiple routing protocols, EIGRP, OSPF, BGP, multiple routing protocols, then such type of router we call it as ASBR. Clear?
Autonomous means
autonomous system. Sorry, I didn't get it.
Meaning this means
Autonomous system border router. That means we are running on one end one routing protocol and the other end other routing protocol. Two different AS. One is EIGRP OSPF. Clear? Now, every router in OSPF will generate type 1 LSA. Here every router will generate it. And type 2 LSA is generated by only DRs, designated routers. What are these DRs? This will be discussing later, but for now remember type 2 LSA is generated by DRs. And type 3 LSAs are generated by ABRs, to inform one area networks into another area. Exactly, we'll discuss it. Type 5 LSAs are generated by ASBRs, in order to tell one routing protocol information into another routing protocol, or else another routing protocol information into OSPF.
You don't mention here R6.
Internal. Clear? And Type 4 is again generated by type ABR itself. And why does it generate, that we'll be discussing later. But remember, type 4 is also generated by ABRs. There. So type 1 is by everyone. He will generate, he will generate, he will generate. Type 3 I'm writing it with black ink. Type 3 only by ABR. And type 5 only by ASBR type 5. Here. And this will be reflecting onto all the areas without any change. So these are the LSAs. Link state advertisements. Link state advertisements. Clear? Yeah. And else if I start now, they will not be finished. Have your lunch and we'll meet at 2:30. Okay, and then we'll discuss LSAs. Type 1, type 2, type 3. Yeah. Yes. So the next we are going to discuss about the type 1 LSA. Clear? And as part of CCNP, we will be discussing this type 1, type 2, type 3. And 4 and 5 also a little bit, and what are their purpose, and that we'll be discussing. But for now, we'll be discussing 1, 2, 3. Clear? So type 1 LSA. First thing, LSA, link state advertisement. Yeah. So link state advertisement, right? Usually what happens is, I'm telling you in brief and so that you can understand what is an LSA, right? What actually happens is, two routers, they will be exchanging hellos, and they'll come to know, yes, never should be done. They will be exchanging DVDs. In these DVDs, you will have nothing, just you will have the route information. I have so and so router's information, you have so and so router's information. Out of this, what information do you want? Like what? You will be going into a restaurant. In the restaurant, you will be having much item, recipes and everything, but you don't have anything. You will be having a menu through which you have to order. What do you want to eat? The same thing here, DVD. It is like a menu. Upon inspecting this DVD, every router will send a link state request. In the DVD, it will have router IDs. What information do I have? With me. See, you and me are the routers. We are running OSPF. We'll form the neighborship, and then I will send you my DVD, database descriptor. Whatever the database I have, it is not complete, but I will give you a summary, and that summary we call it as database descriptor. Clear? Whatever I have, I will give you a DVD, and whatever you have, you will also give me a DVD. Now I will check mine. Oh, what I have, and what does others have? I'll compare both of them. Okay. If anything is missing in mine, I will send you in an LS request. I'll send you an LS request, bro, I want please this information to me. And now when a router, you have received an LS request from me, you will send me an LSU update. And in this update, you will be sending me routing information. How? In the form of LSAs. In the form of LSAs. Or in simple terms, routing information in OSPF is called as LSA. Clear? And for these LSAs, we have different types of LSAs. Type 1 LSA is known as router LSA. And each router create type 1 LSA for itself and floods it throughout the same OSPF area. Okay, if these are two routers, this is some area. When I will give this command network, my router, it will check, yes, this is in area 1. Then immediately it will hellos and neighborship is formed. Then immediately it will generate an LSA1. It will generate an LSA1 and it will multicast it. Oh, it will multicast it. Here. And what does it contain in this LSA? 1. It will tell what is its router ID. Okay, in every LSA you will be having two important fields. One is LS ID and the other is advertisement router ID. Advertised router ID. Clear? Now LS ID will tell you what is this network. Understanding it? See, I am sending you an LSA. What for? To tell you an information regarding a network. But regarding which network I am telling you? This LS ID will tell you what information is it, what network information is this carrying. And advertisement router ID, if you want to go to this link state network, you have to go to this advertisement router. Understanding it? Okay, so these are the two important fields. And along with this, it will be carrying cost, link count, everything, and type of link. Clear? This LSA identifies an OSPF router based on its OSPF router ID. And in an LSA1, type 1 LSA, both LS ID and advertisement router ID are same, and that is the router ID of that router. Router ID of that router. And all type 1 LSAs for the same area will be listed under this. When you type show IP OSPF database, router link states for area so and so, and this under this, whatever the information you are finding, those are called type 1 LSAs. And how can you see it? With the command show IP OSPF database. And if you want to be particular, see what actually happens is when you give this command show IP OSPF database, in real time scenario, your router will be connected with hundreds of routers, right? And you will be having a pages of replies output, but you want to filter to the one you want. And how can you do it? Show IP OSPF database. From which router ID do you want this? Give his router ID. Clear? Database. This is the command I'm using to check complete my OSPF database. And on which router I'm using? I'm checking on router 1.1.1.1. And what is its process ID? 12. Router link states. For which area? Area 1. As my router is part of only one area, I can see only for that particular area. And these are the LSAs. It is saying that there are two routers in this area. Understanding it? There are two routers in this area. What are their names? 1.1.1.1, 23.2. What is their age? Here, actually, it will be 1800 seconds. Okay, and every 1800 seconds, once they receive LSA, one more new LSA, it will be recycled to 1800. And they will be having a sequence number to avoid loops, checksum obviously, and the link count. On 1.1.1.1, for on this area, how many LSS do we, how many links we have? Only one. And 23.2 router, how many networks do we have? Links do we have in this area? Only one. Clear? And if you want to see this in detail, router and 23.2. Database of router 23.2. I am checking in 1.1.1.1. What is this LS type? It is type 1 LSA. LS ID 23.2, advertisement ID 23.2. Sequence number of that LSA, checksum. What type of router is it? This particular 23.2, it is an ABR. And how many links are they connected in this particular area? Only one. And what is that? That is 12 network. Clear? 12 network. And you can see here 12.2 is interface IP, or else if it is designated router address and router interface address. Okay, what are these? That will be showing in understanding in the next slide. But how many links? Only one link. Clear? Clear? Yeah. OSPF identifies type 1 LSAs using 32-bit link state identifier. Okay, and what is the 32-bit link state identifier? It is the router ID of that particular router. Which router is generating that LSA? That router's router ID is the LS ID of that particular LS. Clear? And when do we use this? If suppose ABRs can create multiple type 1 LSS for themselves, one per area, and OSPF speakers will generate type 1 LSS by default. Whichever the router is running OSPF, it will generate type 1 LSS at any cost. Okay, if we check on ABR, let us think here R2 is our ABR. Sorry. And if you can see here we are having a plenty amount of LSAs. We will go to a single area and such that we can understand it. Clear? We'll go for area 1. Yeah. This one, this one, this one. These three are of area 1. Router LSAs, type 1 LSAs. It is also having the same database as R1 is having. This is for area 1. Similarly, we will be having router LSA for area 0 and for even area 2. How many areas the ABR is connected, that many areas router LSAs will be listed in that particular ABR. Now our ABR R2 is connected to area 0, 1 and 2. So you can see here router LSA for area 2, router LSA for area 0 and router LSAs for area 1. Here. And what does this router LSA here in area 0 say? There is only one router in area 0. And in area 2, there are two routers, one with router ID 3.3.3.3, one with router ID 23.2. Clear? And our router LSAs include some information about its attached links. Okay. If interface with no neighbors, okay, our router will classify the interfaces or networks, okay, and according to that classification, it will give the information to the neighbors. For suppose if our router is having an interface, whether it is physical or logical, where the router has no neighbors on that particular interface, such type of networks, router will consider them as stub network, a network where no neighborship can be formed. No neighborship can be formed or neighborships are not formed. Such type of network, it is called as stub network. And in such type, when it is advertising such type of networks, along with this type, a stub network, it will also send subnet number, that is network ID, and also the mask of that network. Clear? Interface with DR. Neighborship is formed. If neighborship is formed, that means on this state, on this link, if you are having a DR connected, designated router connected, then that link, it will just tell the IP address of the DR, okay, and it will state that link as transit network. It will state that link as transit network, okay. And remember, now who will tell the subnet ID, that is network ID, and subnet mask of this particular network where interface DR is connected? That is a responsibility of DR. On this interface F0 by 0, I'm having 12 network connected. When I'm advertising this LSA to my neighbor or through that area, I have seen that on this interface I'm having a DR connected to me on the other side. Then what will I do? I will send the LSA just with IP address of my DR. What is my IP address of DR? 12.0.0.2, and I will mark it as it is a transit network. Okay. When multiple routers are connected, they are connected to a switch. everyone is sending LSA type 1 LSA on this interface to this area, but telling that link ID is 12.0.0.2. Instead of network, they are telling DR interface IP, and they are telling that this is a transit network. Upon receiving, these routers will understand, yes, we are all connected to a single DR. But what is the network ID of this? And what is subnet mask of this? Who is a DR? Let us think he is a DR. He will generate a separate LSA to tell what is this network and subnet mask. Only the DR has that responsibility. Here, but non-designated routers, they will generate it with the IP address of the DR, and they will tell it as a transit network. If you are having a point-to-point, that is, there is no DR. Okay, in such type of scenarios, it lists the neighbor's router ID, and it will tell that it is then connected to another router point-to-point. It will tell that it is a point-to-point link, or it is connected to another router. Okay, the question is, now who will tell this subnet ID and subnet mask? When you are having a point-to-point link, our router will generate two type 1 LSAs. Sorry, in single type 1 LSA, it will make two entries for that two entries for that network. One, it is telling it as point-to-point, another router, and the other is, it will mark it as stub network, and it will tell what is the network ID and subnet mask. Clear? Understood? So we'll see a small practical of this. One by two. And what will I do is, I will just advertise one. Okay, and on the other side, I didn't advertise it. Okay, database 1.1.1.1 link count has increased to 3. YC show IP OSPF interface brief. On this router, how many interfaces are enabled with the OSPF 3? So that is why link count has gone to 3. Here, and if we see show IP OSPF database router 1.1, router LSA link state ID 1.1.1.1, advertisement route ID 1.1.1.1. How many number of links? 3 links. It is a stub network. 1.1.1.1, 255, loop back 1. As there is no neighborship, no neighbors can be formed on this network, so it has marked it as stub network. Clear? And in the same way, 21 network also. It is not having any neighbors on this 21 network, so it is mentioning it as stub network. And if you see the cost here, matrix 1, It is 64. And a transit network, it is mentioning it as a transit network, but what is link ID? Designated router address. DR address is 12.2 and router interface address is 12.1. DR is 12.2. In link data, I am having my interface IP address, that is 12.1. That's it. Clear? Now, who will tell subnet mask of this information? Subnet ID of this link? DR will tell that information. Clear? Right. Have you understood what is the stub network and transit network? Now, what will I do is I will enable on serial 1/2 of R2. I'll advertise it in OSPF and we'll see the change. Let it form the neighborship here. I got the neighborship up. Now, if you go on R1, earlier I was having only 3 links, only 3 link IDs, but now I have 4. Why? This is same, but there is a change here. It wants to tell this as a point to point, right? And it has formed a neighbor on this ID, on that network. So immediately it has told this is another, it is connected to another router and it is a point to point link. Who is the neighbor on this link? 23.2. Neighbor link router ID is 23.2. He is my neighbor. And what is my interface address? 21.1. My interface address is 21.1. But earlier it was telling subnet mask and network ID. That is here. Okay. So whenever you are having a point to point link, our router will generate 2 entries for this single network. One as a point to point link and the other as a stub network. Clear? And if we see the same thing from router 23.2, we are seeing it for area 1, and in the area 1 you can see it is generating 3 entries. Who is generating 23.2? For which area? For area 1, right? For the network 21.2, it has neighbor as 1.1.1.1 and 21.2 is his interface IP. Regarding that same network ID and subnet mask, and then the transit network. Being a DR, I will also generate the same entry as designated router address 12.2. Router interface address, my interface address is 12.2. Here.